Hello scholars, Mr. Masood here with another exciting lesson from the COSMOS Educational Toolkit. So today's lesson is about Dijkstra's algorithm. What's Dijkstra's algorithm, you ask? We'll get to that in a second. Before we get to Dijkstra's algorithm, we have to understand what an algorithm is. We'll review that in a second. But right now, I want you to plot these points in your notebook on graphing paper. So you would plot all of these points in your notebooks right now. Good, you plotted the points in your notebooks. Now I want you to find the distance between these points. So what is the distance from the dance academy to home? What is the distance from home to the sports complex? So the way you would do it is you count the boxes. So there are 1, 2, 3, 4, 5, 6 boxes between dance academy and home. Remember, you cannot go diagonally right now. Now you would have to find the distance from home to sports complex, from sports complex to the market, and so on and so forth. All right, what is an algorithm? Let's review this. If you want to review this, see my previous video, check out the link in the description below, and you would know what an algorithm is. While you're watching the video, this is what I want you to do. I want you to take notes. See, while you're watching the video, write down something that you noticed, something that you agree with, something that you disagree with, and some questions that you might have while you're watching the video. This is so you can solidify your knowledge and you have a reference to come back to. All right, go ahead and watch that video. All right, so for our next activity, I want you to write down in your notebooks, you are planning a journey from your home to Times Square. Okay, what are some of the factors that you have to consider while planning a journey from your home to Times Square? Write it down. I'll give you a minute. All right, so the factors that you have to consider while planning a journey include if it's the shortest distance, what's the shortest route? The minimum time, which way takes the minimum amount of time, and what way has the minimum cost. So you might want to go on a car because it has the shortest direct route from your house in the Bronx or in Brooklyn to Times Square, but it will not be the shortest time because, let's face it, New York has terrible traffic. Now, the minimum time might be taking a train from your home to Times Square. That might be also cheapest. Another way might be taking Uber from your home to Times Square. That might be the fastest, but it might not be the cheapest. So you have to consider the shortest distance, the minimum time, and the minimum cost while planning a journey. So keep that in your mind, and we'll come back to it. All right, what is an algorithm? An algorithm is a fancy to-do list for a computer. That's all. Algorithms take in 0 or more input and give 1 or more output back. I'll explain that in my own words. So algorithm is like a recipe. You know, you have your ingredients. That's the input. And then you have your output. That's the dish that comes out. So you put in carrots, chicken, tomatoes, cilantro, salt, pepper, and chicken, and some noodles, and that's the input. And then you have an output of chicken noodle soup. Algorithm is the same way. You have your input, and then you have your outputs. All right, now we'll talk about efficiencies. This is a problem from a class of problems in computer science known as the efficiency problem. So this is a traveling salesman problem. We're not going to do the traveling salesman problem, but I want you to think in a broader perspective why this is relevant and why, you know, computer scientists and as scholars, we might think about these problems and how today's lesson is related to this efficiency problem. So a traveling salesman problem is that you're a traveling salesman was selling things going from city to city. People used to do that, and I'm pretty sure people still do that. They go from one city to another selling a merchandise, let's say vacuum cleaners. So you go from New York to Boston to Connecticut to Ohio to Chicago, all of these different cities. So you want to find the shortest route, the most efficient route, so you're not wasting time traveling. So this problem finds the shortest route while visiting all of these cities. So I just want you to remember that, put that in the back of your mind. We'll come back to it and we'll try to connect today's lesson to this efficiency problem. All right, efficiency is also related to optimization. In computer science, the word optimization means it's a process of modifying a system to make some features of it work more efficiently or use fewer resources. In other words, a computer program may be optimized so that it runs faster, or it requires less memory, or it requires less energy. So all of these things are optimizing your system. This is a branch of software engineering and in computer science as well. So now, Dijkstra's algorithm. What is Dijkstra's algorithm? It's an algorithm that works on a group of things connected by distance. So it can be a mat, it can be routers, anything that can be connected by distance. It finds the shortest way to move from first thing to each other thing. So like the map that we talked about in the beginning. So you would go from the sports complex to your house, to the movie theater, and to every other point. So it finds the shortest distance from the starting point to all the other points. It's the fastest, it's faster than many other ways to do this, but it needs all the distance connected to these points or things to be 0 or more. You cannot have negative distance. In other words, Dijkstra's algorithm is a graph algorithm. It is used to solve single source shortest path problem for non-negative edges and costs. So don't worry if you don't understand what edges are, what paths are, what vertices are. We'll come back to it, and there are other resources on the Cosmos website that you can click on and see what these words mean. So it takes a source vertex and finds a path with lowest cost between the source vertex and every other vertex. So it finds the shortest path from your starting point to all the other points. This is a video explaining how you graph using a Dijkstra's algorithm, and how you fill in a grid using Dijkstra's algorithm and find the shortest distance from all of these points. So the link in the description is for this video, see below. And once again, while you're watching the video, I want you to write down something that you notice, something that you agree with, something that you disagree with, some questions that you might have. And I'm pretty sure you will have a few questions for this video. Let's pause it right here and watch the other video right now. Now, Dijkstra's algorithm is basically find the shortest path in a graph. It is used in many fields, including computer networking, routing different systems. It also helps application in Google Maps, going from one place to another, and it finds the shortest possible path from one location to another location. In biology, it's used to find network model in spreading of infectious disease. So if one person has an infectious disease, how it's carried to another person from point A to point B. And it's also used in IP routing to find open shortest path first. It is also used in telephone networks as well. Once again, it's used in shortest path, geographical maps, finding a location from point A to point B, and telephone networks and IP routing as well. It's also sometimes called A algorithm. Here's another video explaining what it is and how you can use it to figure out the shortest path. Now this document explains how do you work step by step Dijkstra's algorithm. But if you watch this video, this is explaining the same exact thing. And I've also attached a document in COSMOS website to explain this further. Now we have this problem. You know, this weighted graph represents a town. This is your house, this is the movie theater, this is your friend's house, and this is the gas station and the grocery station. So you have to find the shortest distance from your house to all of these locations. How would you do it? And what is the shortest distance? So this graph is weighted, meaning it has a value attached to it, meaning the distance from your house to the movie theater is 3 minutes. The distance from your house to gas station is 2 minutes by car, and from your house to the grocery store is 4 minutes. You don't know the distance from your house, the shortest distance from your house to Divya's house, because they are not directly connected. So right now we don't know what the shortest distance is. So we will figure out how to find the shortest distance using Dijkstra's algorithm. So Dijkstra's algorithm is a step-by-step process we can use to find the shortest path between two vertices in a weighted graph. So these are two vertices, and this is a weighted graph. This algorithm enables us to find shortest distances and minimum costs, making it a valuable tool. All right, in your packets, this is the problem that we have to solve. You have to go from point A to point B, point A to point C, and all the other points, and you have to find the shortest distance. Let's use Dijkstra's algorithm to solve this. So the shortest distance from point A to point A is 0. You know, you start at point A, you end at point A, so you haven't spent any time. There is no distance, so the shortest distance is 0. Now you're going from point A to point B. From point A to point B, it's 1 millisecond, and you would write 1, and you write a subscript A, indicating that you're coming from A to B, and it takes 1 second. The shortest distance from A to C is 5 milliseconds, so you would write 5, and once again in the subscript you would write A because you're coming from A to C. And you would write an infinity symbol from A to D because A is not directly connected to D, and we don't know what the shortest distance is right now. We would do the same thing with E. And then you would pick the shortest distance and go on to the next column and next row. So this is a problem that is given on the COSMOS website, and I have a separate video solving this problem, but I want you to attempt this problem on your own and see if you can find the shortest distance using Dijkstra's algorithm. This is how you would start this problem. This is just a hint. So you can start working on this problem on your own. After you're done, you can go back and watch my other video where I explain how to solve this problem. So in summary, Dijkstra's algorithm is an algorithm for computing the shortest path between two vertices of a graph where all edges have non-negative weight. So in other words, it's a way to find the shortest cost, shortest distance, shortest path between 2 points, and they have to be connected by non-negative numbers. So the minimum you can have is 0. It's based on repeatedly expanding the closest vertex. So you find the shortest path, and then you take it from there. What's the shortest path from there? So if you find the shortest path from point A to B, then what's the shortest path from B to C, and so on and so forth, until you reach all the points on the graph. I always like to include additional information, so you can watch this video on how the internet works, how Wi-Fi and cables and wires connect the internet together. It's not directly related to this topic, but it's a neat little video that I want you to watch. See the link in the description below. Same thing with this video. Any questions, concerns, comments? We would love to hear it from you. Thank you very much. Have a great day. And once again, this is Mr. Masood signing off from COSMOS Educational Toolkit. Thank you.